I've never made a game before. Emilia, my wife, she has previously shipped a game called Dreams over at Media Molecule. As for me, yeah, no game dev experience, and so naturally we decided to skip the whole small games phase and just jump straight into an expansive, lore-rich, history-rich, character-heavy action platformer / Metroidvania. What could go wrong? I'm MJ, and welcome to the Maskborne devlog. Here's everything, not everything, here are most of the things that we did in the past 6 or 7 months for the development of Maskborne. Step 1, you want to learn to make games. What do? You find an engine, spin it up, and you just start doing stuff. The engine that we landed on was Godot. Not for any particular reason. I like that it's open source, but other than that, it looked intuitive. I like the node system. So we just went with Godot. And so far, I'm enjoying the software. One of the key things for me is I'm a big movement guy. I like tight controls. I've played a lot of Smash Brothers and fighting games in my life, and so I like the concept of spacing and being able to just move outside of range of your opponents and then strike, when the opportune time comes. So movement was essential, and that was the first thing we did. We just took blocks, built some basic levels, and started messing around with movement, trying to figure out, looking at games that had really tight movement like Ori and Hollow Knight. And so we sort of analyzed and figured out, okay, what do we want to do? And so something semi-fast paced that still leaves you with full control is sort of what we're going for. After most of that had been resolved, I figured out that it was really bad to keep everything in one document or one script with a bunch of if statements. So I had to figure out what a finite state machine was, get that integrated, convert all of that into different states, and that meant that it was more upgradable, it was easier to tweak, edit, and debug because I didn't have to go through a script that was like 1,000 lines of code. Instead, if something's not working with the dash, well, I can just check the dash state, and then we edit that and we fix it that way. Having having done that, the basics of that, my wife started creating some basic art, so we just had a semi-pretty level to actually run around it. And I think it's both our biggest strength and our biggest weakness, that we come from an art background, both of us. I don't know, for the past 20 years or so, we've been doing art-related stuff. And we like pretty things. We like things to look nice when we do it. This has led to some problems because it also means that instead of prototyping and doing things ugly in the beginning and then refining, we tend to overdo it in the beginning, which leads to problems down the line if we need to reiterate. Something to keep in mind if you're like us and you like to make things pretty too fast. But speaking of pretty, one of the main stylistic references for us has been Ori, both the Blind Forest and Will of the Wisps. The amount of depth that they've been able to create in those games has been incredible, and so that's sort of like our goalpost for prettiness. Shoot for the stars and all that. I'm not sure we have the ability to actually reach Ori levels, but with that being our goal, if we fall short, it would still be incredible. So Parallax was something that we tackled very early on. I built a system for this, and it's been upgraded many times because it was just one of the first things that I tried to build, and I didn't know a lot, so I just kind of went with it, and it's been optimized heavily. And at this point, we have a system that allows us to create background elements or foreground elements. We can blur them on the fly. We can sort of preview it in the editor without having to, actually run the game, place things around, and really try to make nice compositions with the tools that we've created. We have blur, we can decrease the quality. One of the things that was really nice, which I got from a Reddit post by the creator of the game Taito, was that he was sort of like the inspiration for this whole system for me. And so what we've done is we've put things into sub viewports, both foreground and background elements, and they then get blurred. So we do a 2-pass Gaussian blur on each element, I would say. And that gives you really nice and smooth blur. The problem is it's also kind of expensive. So for the very foreground and the very background elements, we can step down the resolution. So take the very foreground, for example, instead of rendering that at 1080p, we scale that down to a quarter of the size and then blur that quarter, scale the quarter size up. And because we're blurring and scaling at the same time, we need to use less blur and it renders less pixels. So it's a great way to optimize. And if any of this sounds interesting to you, feel free to subscribe to the channel. It really helps a lot with visibility and getting more viewers to the channel, as well as checking out our Discord where we post updates pretty much daily at this point. Now, something that I haven't covered before is how we actually get assets into the game, because this was like a mystery to me. You know, I'd seen texture atlases from other games that were 2D or 2D, kind of 3D, but you know, flat games, and they were all like super tightly packed. Godot doesn't have the ability to do that or read that very well, because the way that its texture atlases work is that everything is grid based. You can do regions, but it was like kind of messy. So I found a software called Texture Packer, and that's sort of like been the backbone of our entire workflow of, you know, authoring assets and getting them into Godot. So at this point, it's pretty simple. My wife, she creates a texture atlas. I take that texture atlas into Texture Packer, split it up. Now we have a bunch of textures. I take those textures into a software called Lighter, where we create normal maps from those textures. Normal maps are a huge part of the lighting system, or like how we give fake depth to our assets. Something that I'll probably cover in a later devlog. Too much for now. But anyway, we have normal maps and normal textures. Take it back into Texture Packer, and then we pack everything in an optimized way. The cool thing with Texture Packer is that it comes with an integration for Godot, so you just load that in and it just does everything automatically. I haven't really done this yet for the player animations, but it should still be possible. I just need to actually do it. After parallaxing, another big thing was AI. Not that kind of AI, but the AI for the enemies, right? So the first thing we did, took the player, duplicated, make it red. Evil player. Now we have something to do stuff with. And so after the whole state machine debacle, I didn't really feel like doing more of that. And so I found a plugin called Limbo AI that does the whole behavioral tree for you. I mean, it doesn't do everything for you, right? You have to still do stuff, but it manages the behavioral tree. Limbo is great, and it serves us very well. It handles all the states that we really needed to, and so far I've been very happy with that solution. Now, I think where things became really tricky was pathfinding, and I'm sure a lot of you can relate to that if you've done that. After a lot of research and I was looking at Unity, I figured out that Unity was, I don't know if that's the default or if it's just an algorithm that's available, but the A-star algorithm is what we settled on, because I saw they had that in Unity and there were a bunch of tutorials for it, so it looked pretty good. So I read up on that and we implemented that. Godot already has A-star, the actual algorithm in Godot, so that made it obviously a lot easier. The tricky thing here was all the edge detection and avoidance, everything, you know, just going A to B when you have a player and an enemy. Fine, that's easy. But with flying enemies that have to fly around platforms, and maybe they have to take into account other enemies and fly around those, who gets priority for what? But, you know, with enough pain, we managed to get through that as well. And right now I think we have a decent system. We haven't really gotten too much into the whole enemy boss territory yet, so it's still kind of basic. But I think we have a good foundation for when we actually start really developing that. All right, for some visuals. A big thing, again, visuals for us. Glow. I know I love Glow. You know, I'm a sucker for Glow. I've been working in After Effects since I was like 15 years old, and I don't know, I just love Glow. So I knew I wanted the characters to have that as well. Initially, we used the environment 2D node that Godot ships with, but for performance, it was pretty bad. And so we came up with a solution where for the enemies and the player, if you have like a 100 by 100 square, that's the actual sprite. Then what we do is we add some padding to the actual asset, And then within that, we apply glow. So instead of the whole screen having to glow, we only glow the very specific pixels around the player and the enemies, and we save a ton of performance on that. It's not as smooth as the 2D environment node, but I think for what we need, it's good enough. Continuing on from the glow, I guess this is kind of in the glow territory as well. I love this ethereal trail that they have in Ori. You know, when Ori is running through the forest, there's this trail coming off of Ori. And I feel like, you know, that's kind of a staple almost in Castlevania games in a way. But I didn't want that copy, like ghosting image. I wanted that Ori feel where it was smooth and it almost felt like smoke in a way. So every frame, the emitter measures how far the player has moved, and then it drops a what we call stamp along a path once it's traveled far enough. Instead of spawning real sprite nodes, we found that to be pretty expensive. Every stamp is a single instance in a multi-mesh. That means hundreds of these stamps cost basically one draw call. The look itself just comes from a shader. Each trail ages from a shared global clock, and as it ages, it drifts, it warps, we have this curl noise, turbulence, it erodes the edges, and then fades out. I then extended this to our projectiles as well with some tweaks, and we're able to get a more fiery incense smoke type of effect. And it's really easy to apply. We just have the node, hook it in, and it just works. While we're in this effects visual phase, something that we wanted to add as well were shockwaves, camera shake, and exploding spatter for enemies and death and particles. So we did a bunch of that at the same time. As I was doing that and I was adding it to our levels, I started noticing lag spikes or load spikes, I don't know. And so I read up on it and figured out, okay, you need to preload stuff and warm stuff up in the shader before doing it. Because if you do it the first time with the player is going to see that spike. I'm going to get more into that later because this wasn't like the full solution, but we'll cover that a little bit later. Now, moving on to our ingredient system and our bonfire, which is called Soot. So ingredients are just as you know them from Breath of the Wild. Enemies and things around the world can drop ingredients. These ingredients you can consume for a one-time, time-limited buff, or gather enough and with the right ingredients and the right recipe, take them to Soot, and then Soot will allow you to create Boundlings. Boundlings was something we covered more in depth in the previous devlog, so if you want the full lowdown on Boundlings, go check that out. But essentially, Boundlings are your equipment. It's your armor, your weapon. You do have a sword, but it's kind of a bit of both, right? Boundlings are able to give you stat boosts, and extra abilities for you to take with you on your runs. As for Soot, he's so far one of my favorite characters. Soot is a being from another dimension, essentially. A very powerful being, but when you meet him in the game, confined to a little flame, right? One of the very obvious inspirations for Soot was Calcifer from Howl's Moving Castle. I've always loved that character, and I feel like it fits so well with what we're trying to do. But obviously we have to do our own thing. Right now, he has, just like everything else, an animated sprite sheet. And those sprites, in the beginning, were just placed on the fire. And it looked kind of static because we wanted them to engage in a way. So I took to Reddit, as you do, looking for advice. That's, a trap sometimes. But this time it actually paid off. Someone on Reddit, recommended that I wanted to rotate based on the player. That we do that in a 3D scene, like on a sphere or something, as a sub viewport in the game. So that's what we did. I took a sphere, I mapped the textures for Soot onto a sphere, and then into a sub viewport that we can render in our 2D game. So Soot is 3D for all intents and purposes, but what we're seeing is just a 2D image of that 3D sphere. And so based on the distance from the player, Soot will be offset on that sphere, or the sphere will rotate, right? So if the player's over here, the sphere will rotate more towards the player, so when we run by, it actually sort of looks at the player. All in all, it's a very simple system. I just didn't know that you could take a 3D scene and put it in 2D. Continuing in the vein of bringing more life into any game, I guess, is all the stuff that happens in the background or on screen that you as the player don't necessarily have control of. This could be a flock of birds, particles, or in this case, wind and interactive foliage. This system has, like many other systems at this point, been rewritten a couple of times because in the beginning I didn't know what I was doing. It was horrible, rewrote it, better. This particular system, I think I will need to do one more time because there are things that we just can't do with the current implementation. Yeah, but you know, the life of a game dev, I guess. But it's a very interesting system and it hooks up with our shockwaves, which I think is cool. So if you trigger a shockwave or an explosion of some sort, all the foliage in and around you will interact as well. And obviously we've made this adjustable, so a bigger explosion will impact a larger area. And we can have it impact like a very tiny area if we want, but you know, I think, yeah, it plays very nicely together. But the current solution that we have is where we convert the sprites into mesh instances just at runtime. And then we subdivide them to give them some resolution. Usually, I think in the y-axis, we subdivide them 4 times. 1, 2, 3, 4. Yeah, 4 subdivisions. Then depending on the velocity of whatever moves past them, usually the player, they will bend and, you know, bend more if there's a faster thing passing by them. Then they go back smoothly and they start swaying in the wind again. So we've constantly got something happening on screen. I think it's pretty simple, but it's an effective visual tool that really helps breathe more life into the world. Checking my notes, optimization, increased FPS, blah, blah, not interesting, more optimization. We'll just move past this part because it's literally all the time. Water, that's a big one. Also did a full devlog only dedicated to water, so definitely watch that because I'm not going to cover everything here, then it'll just be twice as long. But bullet points. I love Ghibli, whatever. I love the water that they have. It's so magical and so non-watery. Like it's thicker. Like it's never normal water. So we took that as an inspiration and we made that. Reflections, silhouettes, again, everything being adjustable. And we even have enemies that can appear in water and swallow you whole. So there is that. Water, great. Go check out the devlog. Now for something completely different, a custom audio tool. And the audio people out there amongst you might say to yourselves, why would you do that when you have Fmod? I tried looking into Fmod and I'm not an audio person. It was like beyond me. So my wife and I, we sat down and we figured out like, what do we actually need in the game? Right, we need surfaces that have different surfaces. Collisions, right. The collision layer that we have, we wanted different surfaces. Grass, rock, water, whatever it may be. And we built a tool that allows us to do that. Like we can hook anything up to any animation. And then we can alter the pitch, the level, the speed of things, and connect different pieces of audio. It didn't actually take that long to make, and I think it's a solid system for what we need. And the way that we sort of got the whole surface aware thing was with a custom data layer on the collision object, or the tile set, right? Whatever we paint our levels with, that's actually the bounds of the level and the collisions. We have a custom data layer, which just tells whoever's authoring the level what they're painting with. If they're painting with grass, it'll play the grass sound effect connected to that. So each character, in a way, owns their own audio. So for the player will have footsteps. And those footsteps, you can enable these surface-aware sounds. So you can enable grass sounds or for the footsteps, or rock for the footsteps. And the same thing for attacks. So it's all this holistic system. Everything's connected. And if you change one thing, it updates everywhere. Personally, I feel like it's a good solution, but I'm not an audio guy. I don't know anything about audio, which will present a challenge later on, I'm sure. But for now, I feel like it's okay. But honestly, if you have other suggestions, please do let me know. Then came a big one, especially for my wife, because she had to redo all of the animations. Not just because we did them very early on and they needed to be updated, actually, but because we decided to update the character design. And with an updated character design comes new animations. So I think that was sort of like 4 months into the project. And over those 4 months, I mean, she got a lot better at animating. When we started this, she had never animated, right? So this was really a trial by fire for her as well. So she got started on that, doing all of that. And I think we are so much better off. The animations are smoother, they're higher res. And I think with the new design, it's just more readable. Like the character as a whole is not just fully clad in white. There are actually accents there and there's contrast within the shapes. Now, for a thing that I'm genuinely proud of, because it was like my own brain came up with a solution, and that feels amazing. I mentioned the 2D environment node earlier in the devlog that we tried to use for the player, but obviously the 2D environment node, a world environment node, it can do glow for everything, right? So both the player and the world, everything will glow. And I really wanted that, but I didn't want the performance hit that came with it. So the background for the UI is a real-time blurred version of the game with the UI on top. And so the way that we do that is we take basically a live screenshot of whatever's happening in the game at 1080p. And then we scale that down to like a 16th, 1/32nd of the actual resolution. And then we scale it up bilinearly. So we do that, and that gives you, I mean, perfect blur without actually having to do blur. And if you know anything about compositing and blur, that's kind of how you get glow. You just have a threshold for the brightest areas, and then you let that shine through with something like a screen overlay, for example. And that worked. I mean, I did it for the UI with the blur, and I thought that was pretty smart. And I was like, can we maybe just do that for the actual glow? And we could. And the cool thing is, because we're just piggybacking off of whatever's on the GPU already, it's like free. I mean, it costs maybe 1 or 2 FPS, so negligible that it doesn't make sense not to have it on. Eventually, we might replace what we have on the player and the enemies with just this. I'm not quite sure yet, but this is what we have. And at the same time, I created a small grading tool plus some grade presets. So what we can do with that is that we can take the world and we can color grade it. We can add brightness, contrast, color balance, all that good stuff, saturation. And then I added a counter grade node for all the characters and the enemies and the player, meaning that if we overgrade something, if we have to overgrade something like a level to get just what we're after, and maybe the player in that case is super overblown, we can enable the counter grade, which removes all grading on the player and just leaves the player at default. You obviously have to be a little bit careful with this because the player still needs to feel integrated, but it's a nice grading option, and it kind of works like compositing where you have everything on different layers and just allows you a lot of flexibility. And honestly, I think it's a cool system, and I'm happy I spent the time doing that. Then for a big thing I haven't actually talked about before, because that's new since the last devlog, and that's summon attacks, or summons. The one half of Boundlings, right? As I mentioned in the previous devlog, we have boons and we have summons. Those are the 2 types of Boundlings that you'll be able to get. Summons are Boundlings that you equip mapped to certain keys, and they allow you to basically cast, I guess, spells in the world. And so the first one we created here, I don't know if it'll make it into the game, I hope it will, because it's pretty cool, is this tentacle Boundling, right? So animated with tentacles everywhere. And when you summon it in the game, tentacles sort of like explode out from the player, and a massive shockwave appears, pushes all the enemies around you away, and also damages them. We kind of had to do this now because we're working on some teaser shots, and they were just a lot of really basic things that we were still missing, like how we do the actual creation of things, ingredients, all of that. But again, a lot of that is covered in the previous devlog, so I don't want to spend too much time on it. But the summon attack, pretty cool. It's in there, and it's sort of like the first special attack of the game. So back to the whole warm-up manager for shaders and effects. The thing that I made a long time ago that turns out didn't really work that well. You know, after all this was said and done, we got things running on the Steam Deck, which I was very happy about. And for the most part, it ran, you know, it capped out at the 90 FPS, which I think is like the max that the Steam Deck shows by default. But whenever any action happened on screen that would spawn anything, like the summon attack, the FPS would just drop to like 60 or 50. And I like kept banging my head into the wall, like, what is this? Because I made the warm-up manager, right? So I wrote a bunch of debug code to figure out what was actually happening. And it turns out it's warming up some things, but not all things. It was only warming up the things that were on screen when the player was spawning. So if we had an enemy on screen, it would warm up its effects. It would try to do it for all the other enemies as well, but because they were off screen, I guess they're not drawn, they're not in memory, they're not on the GPU. So we amended the warm-up manager a little bit, and basically what we do, I have no idea if this is a good solution or not, but this is what I came up with, so, you know, feel free to give me feedback. We spawn a camera at the beginning of the game, right? As you start compiling everything in runtime, black screen. And under that black screen is a camera. That camera goes to each entity that's in this warm-up manager script and then warms it up. Like it forces it to display its particles, its shaders, everything. But only for like a couple of frames and then moves on to the next. And if there are multiple entities within that, it won't obviously go back to those. So it's a little bit efficient. I measured the time it took, like the startup time. And without it, I think we had a startup time of something like 400 milliseconds. With it, 600 milliseconds. And this was in a level where there was like 40 enemies, I think. So if it stays like that, I can definitely live with it. But again, I'm sure there are a bunch of different, better ways to do this. So, you know, again, if you have ideas, please do let me know. Sort of like a secondary demon, aside from the UI, which I talked about in the last devlog, cameras. My God. I've been using the default Godot camera for a while, and it works fine. But I needed to extend on that functionality. And the standard advice that you get from everyone is download Phantom, use Phantom, it's great. And I'm sure Phantom is great, but I don't know, it just didn't click with me. And it comes with a bunch of other stuff that I don't really need. So months ago, I tried making my own camera. Didn't work. I mean, it worked, but it didn't look great. Like everything was off. The timing, the smoothing, it was horrible. It just made me motion sick. But been 6 months, and I figured, you know, I have more experience now. Let me try it again. And I'm happy to say we do have a custom camera solution now, but it was not free. You know, mentally for me, it was a battle. But it's good. You know, we have everything we need now for. There's look ahead. There was a lot of stuff I had to fix with like how the camera was like bouncing back and forth when you were doing stuff, but we do have a custom camera now. And I think we're going to be happy going forward because I think that's going to make things easier when it comes to revealing secret locations, having focus objects, a custom zoom, whatever it may be. I think this is really going to pay off. And so far, I like the look of it. I've mostly focused on the x-axis, not so much the y-axis, so there's still, you know, future frustration is yet to come, but doing the x-axis has definitely given me the confidence to be kind of sure that I'll be able to fully make it work like I want it to. And for the past month, I think it's been a month, maybe a little bit more, a month and a couple weeks, we've pretty much exclusively been doing prep for our teaser. Now, in game dev, indie dev communities, whatever, you keep hearing about wish lists. You keep hearing about your Steam page, get it launched, do this, do that all the time. And like I say in many of my devlogs, it stresses me out quite a lot because I don't know what to do, right? And so we'd actually decided to just launch the Steam page. Take whatever material we had, just cut some things together and just launch it. But then we started looking at it and we're like, well, you only get one launch, right? And we want that to be impactful. And so we decided, let's make a teaser. And so the teaser was originally going to be like 10 seconds. And then we tweaked some things, shots became longer. We added more shots and more shots. And I think now it's grown to maybe like 40 seconds. So I feel like we're approaching trailer territory. Still teaser. We're calling it a teaser. It's definitely a teaser. But we're doing that so we can launch the Steam page. The cool thing about the teaser is that it taught me that there are a lot of things that you learn that you need, or maybe don't need, when you're making a teaser. Because it forces you to actually create levels. And we hadn't done that before. We'd done test levels, but not real levels with enemies, the way they interact, how you're supposed to run, everything, the UI, Soot, boundling creation, using spells, using attacks, all that stuff had to come together. And so it's forced us to make a lot of things a lot better and create tools, bespoke tools that we need for the production. So let me just take you through a couple of these. One of the tools that we've created is a small attack builder. And all you need is for enemies, bosses in the future, and the player. Just select our rig, the attack rig, and the hitboxes under that. And then a little pop-up over in the inspector is shown, and you can select what kind of attack you want. Just a normal attack, a projectile, or an explosion attack. And based on what you select, it'll create all the correct nodes in the editor or in the outliner, and it'll select all the options that are relevant for that type of attack. And it's already saved me a ton of time. So that's been a great tool. The other one is what I'm calling camera tools. And so far, it's the only thing camera tools is a draggable box for defining the limits of the level. For each level, instead of using the normal, in the camera 2D, you have the limit and you enable limit and you have numbers, but you have to like either input numbers manually or scroll or whatever. This places a rect in the editor in the viewport with handles, like sort of like a default looking handles from Godot, and we can drag out the limits of the level. It makes it really easy to just define the bounds, or if you need to prototype a specific area, you can do that. So that's been a helpful tool. And another one has been boundaries and copy paste. Very creatively named plugins. The boundaries plugin is probably the most useful we've done when it comes to level creation. Because when you have a lot of assets, I mean hundreds if not thousands of assets in one level, it's really hard to actually select things and know what you're selecting. Like some things, I think particles and maybe some things that are character 2D will display a name, but most things won't. So we built this kind of like with the camera tools where we have a rect around things, and when you hover over an object, it'll display the name, it'll display the bounding box for that object. It's what do you say? Prioritizes C depth. So based on the depth of the asset, it'll prioritize whatever's in front. Something you can disable if you want to be able to select everything, which gets quite chaotic. You're also able to turn on all bounding boxes. You can see maybe you've left assets hidden somewhere that you didn't know that you had. And so far this has been a great help. And the copy paste thing is simply just when you select something and you paste it, it'll paste where your cursor is. And also whatever you have selected, it'll paste it as a sibling of it instead of a child. Again, just something that speeds up level creation quite a lot. And something that I want to expand in the future, right now it's very simple, is what I'm calling viewport filters. I added this small sidebar on the right hand side that just has a particle icon. And when you click that, it hides or disables all particles in the editor in the viewport. Not at runtime, it's just a visual filter basically. And I'm going to be expanding that into our background and foreground layers. You have access to like which layers do we want to see. It's quite important when we're creating levels that we can hide stuff and view specific things in isolation. Again, it's the whole, you have 1,000 assets, which ones are you actually, manipulating or wanting to move to the side? It can be a little bit chaotic. That about just wraps up the last 6 or 7 months of my life. I don't know if you can tell by my voice, but I've been talking nonstop for like 40 minutes to an hour, I think. So I need to wrap this up. Thank you so much for watching. In the future, I might be doing other game dev related stuff, not just devlogs. I'm learning so much and I feel like there's value in what I'm learning, and hopefully it's something that I can help communicate to other people who want to create games and are passionate about, games as well. So thank you so much for watching, and I will see you in the next one.